An interesting hypothesis we heard recently was that a quant team was able to look at how weather had a certain effect on the fundamentals of a company of interest. So here's a demo of Sphinx working through a similar inspired example. We're going to think about theme parks, in this case, Six Flags, and we'll try to analyze how rainfall at the parks may have some kind of detrimental effect on the company's revenue, driven by some phenomena, for example, that if it's raining more in a given period of time, people are less likely to visit the parks and therefore generate revenue. So we'll start by giving Sphinx a prompt that I have a hypothesis that Six Flags revenue is lower in rainier quarters compared to not rainy quarters. And to test it, let's do the following. Go make up a list of parks, geolocate them. For each park, go and fetch weather data. For all of this, just use free APIs. Of course, you could connect to your own APIs. And then compare the number of rainy days for a couple of different thresholds to revenue, which we here have prepared in a CSV. You can obviously connect to your existing systems for KPIs to pull that out and do some year-on-year comparisons to see if there's a correlation. So Sphinx will get to finding these theme parks, listing them, geolocating them here. We're going to not be able to find all of them. Some of the parks may not locate properly, and then Sphinx will do some fallbacks, get the coordinates, and then go use the Open Meteor API to go find precipitation data for these locations. Once that data is pulled in, we see that most days, of course, don't rain, especially at theme parks in California, but now we're able to pull in that data, and of course, the revenue data is already prepared for us. Pull that in, try a couple thresholds, 1 millimeter, 2.5 millimeters, 5 millimeters for different levels of rain, and then derive the correlation. Sphinx will here show that it has found it, and there's maybe some kind of negative correlation here, but let's formalize it a little bit. Let's go to Sphinx and ask it to actually properly do the correlation analysis. So it will say, okay, I've obtained the year-on-year data, then the joins, etc. And so it's asking if I want additional granularity, which I do. So please visualize in a scatter plot revenue growth versus rainy day growth in the same space for each threshold. And also just give me the actual raw correlation values so we can build some intuition here. Sphinx will now, of course, read through all its previous work, contextualize it, and kind of give me the work here. It'll build nice plots for me in Seaborn. We'll see what comes out of this. This is already a reasonably interesting conclusion that we can see for the higher thresholds, 5 millimeters of rain, enough that you probably are not going to the theme park. There is actually a pretty strong negative correlation, but we did just try these 3 thresholds. At the risk of overfitting, let's maybe see if we can do a couple more. So I'll pause Sphinx here as it kind of thinks about this plots and say, okay, let's just, okay, 5 seems like the best correlation so far. Let's try something a little bit more aggressive, like several thresholds, and let Sphinx figure out what that means. Okay, it seems like it's going to do a grid search from 0.5 millimeter to 10 millimeters. I think this seems fine. We'd obviously want to have some kind of inductive bias on how reasonable the threshold sounds before we accept it for any kind of application, but we'll let Sphinx go and do this. Seems to have made some kind of like small coding bug in terms of importing a library. You can obviously fix these types of issues. Having fixed that, it will show me this plot, which now I think is quite curious. So as we raise the threshold, it seems like we're actually getting a stronger and stronger negative correlation. So when there are very many significantly rainy days, it seems like 8 millimeters, 10 millimeters of rain, or days exceeding that threshold of rain, seem to correlate to quite a strong relationship with revenue shrinkage. In this case, more rain indicates revenue shrinkage. So let's take kind of a nice round number just at the end of this distribution, the 10 millimeters of rain, and just kind of figure out what that looks like and visualize that and perhaps do some interpretation to show me the scatter plot for a threshold of 10. And of course, this should be reasonably straightforward. So Sphinx will go filter, rebuild the pipeline nicely to show me just that value, and give me this nice code block, which I can now, of course, take and go run in production. And that looks quite interesting, right? So we can see that certainly this is more interesting in the extreme values, and it also seems like there are some periods in this data, which is of course like only the recent quarters for Six Flags. Can't really push back further, given that we might have to deal with M&A, old parks opening, new parks opening, old parks closing, etc. But even within this regime, we can see that there are some examples where there was quite a bit of rain and there was revenue shrinkage, and vice versa. And of course, this is not accounting for any of the other factors that you might be able to leverage from other alternative data sources, and Sphinx can certainly help with that type of analysis. But to wrap this up, let's actually write a summary that we can put in front of someone fundamental, someone who appreciates statistics but may not want to actually read through all the code the same way that you on the quant team might want to do that. So let's ask for a nice markdown summary. It can have the stats. Don't make it fully technical. And obviously, this can be customized to the level of person who you want to give the data to. And we'll reveal this. We've pulled weather data. It looks like we have 10 years of weather data, but we only, as the document says, have only been able to pull actuals from 22. That's more of just we don't really have proper point in time data for what parks are available. We did use an LLM to approximate that. And having done that, we found this Pearson correlation of negative 60%. And therefore, the conclusion is that perhaps this is worth monitoring. If we did have weather forecasting data, for example, we could then use that as a forward indicator or even a contemporaneous indicator using current weather trends to estimate how a particularly rainy season or a lack thereof of a rainy season could lead to some type of predictive power for revenue and perhaps other KPIs such as attendance might be even more related.